All right, so we're going to start with jumping into section 3 of the second chapter of the textbook. We're going to talk about functions first. We're going to do quite a bit with functions in the first few sections here, and ease our way into maybe solving some equations later on today. So functions are the basics of an algebra class. They're where everything kind of happens. We spend a lot of time in 100 and 110 talking about various types of functions. So we want to get the basics of them today. So the first thing we want to talk about are what a function is based on. And a function is based on a mathematical relation. And in an algebra class, most of the time the relation that we're dealing with is a set of ordered pairs. We talked about those a little bit on Tuesday about ordered pairs. And a relation, is a set of ordered pairs. So we're using the set braces. So all that stuff we talked about with sets kind of comes into play here, but we don't do a ton of stuff like intersections and unions and that sort of things when we're talking about functions. But a relation is just a set of ordered pairs. So I'm just going to make up an easy set of ordered pairs for us to talk about as an example first. So the first ordered pair is the x is 1, the y is 2. The second ordered pair is 3, 4. The third ordered pair is 5, 6. There's no set rules about how many ordered pairs have to be in a set to be a relation. It can be one ordered pair is technically a relation out of that, but it's a set of ordered pairs is a relation out of that. In a relation, there's a domain and a range. The domain is the set of all x values. So when we talk about domain, you want to think x values, okay? So the domain for the relation that we have here are going to be a list of all the x values. So 1, 3, and 5 are the x values. So we'd make that set 1, 3, 5. Those are the x values for this particular relation. The range goes right along with that. That's the set of all the y values. So when you talk about range, you're talking about y values. Domain are x values, and you remember on the coordinate plane, you got an x-axis that's horizontal and a y-axis that's vertical. Domain is left to right, how the function moves left to right. Range is going to be how it moves up and down. So when we talk about domain, you're thinking x's left and right. Talk about range, you're thinking y's up and down. So that's how you want to kind of tie this stuff together. So the range for this one just be the set of y values 2, 4, and 6. Okay, so those are those pieces for that particular relation. Relations always have a domain and range, but there are special relations that make them functions. So a function, this is the title of the lesson was functions. A function, my U's and N's look exactly the same. I'm trying to make it better. A function is a relation in which one value from the domain corresponds to one value of the range. That's a real wordy way of saying, kind of the short, easier way to remember this is don't repeat x values. If a relation is a function, the x values do not repeat. Okay? If the x values do repeat, it's not a function. It's still a relation, but it's not a function. Okay? So functions are special relations which the x values do not repeat. Okay? So don't repeat x values. The way I tell this to my high school students when we talk about this is they're all starting to date and everything like that. So I always say, if you want to function properly, don't repeat your x's. And they seem to get it that way. They remember their ex-boyfriends and everything, all that fun stuff. So that happens when you're a teenager. So don't repeat x values. That makes it a function. So we're going to play a little game here called Is This a Function? And that's going to be our first examples. And the thing we're looking for is, do x values repeat? If they do, it's not a function. If they don't, then it is a function. So it's really easy to tell, especially when it's just a set of ordered pairs listed out like 1, -6. The next ordered pair would be 3, 5. And then -2, 4. And then maybe 7, -13. Not really any pattern to that. But the idea is that it's just a relation that we're just trying to test to see if it's a function or not. So the only thing we're looking for, if we're just deciding if something's a function, is look at the x values. The x values are 1, 3, -2, and 7. Do any of those repeat? No. They're all individual, so they don't repeat. So this is a function. So yes, it is a function. Just writing that out. Normally this would be a yes/no question, but I'm just writing out it is a function so we know what we were answering if we look back at our notes there. Sometimes that relation might be written not as a set of ordered pairs, but as a table, like with x's and y's, like we did with the graphs that we were finding ordered pairs with one of the labs from Tuesday. So you might have something like 4, -8, 3, -2, 6, -5, and maybe 4, -6. And it's just written as a relation in a table format this time. It's the only difference in that. So we're, again, just looking at the x values. So we're looking at this column here. Are there any x values that repeat? Yeah, that 4 repeats. It's got a different y value with it each time. And that's an illegal thing when you're trying to be a function. You cannot repeat the x value and have a different y value with you. So this is not a function. Not a function because we repeated x value. In this case, it's the 4 that was the repeated x value. You cannot repeat x's and be a function. You got to have. It's okay to repeat y's though. Y's can be repeated. X's just can't be repeated. All right. Next one. Sometimes they will show you a relation, maybe in a different format. And this format, I'll call them bubble maps. And it's called, in a lot of books, you'll hear it just called a mapping. I call it bubble maps because it's like just two basic, two bubbles here. One bubble is the domain bubble, and one is the range bubble. And in the domain bubble, you might have numbers like 4, 6, 7, and -3. And in the range, you got the y values, obviously, because domain's x's, ranges are y's. And you might only have numbers like 100, 200, and 300. The mapping part of it, it's called a bubble map. They map the domain value to the range value. So this 4, the way they map it is they just draw an arrow from the 4 to the y value that it goes with. So what that's saying is, hey, we've got this ordered pair, 4, 200. The x value is 4, the y value is 200. So it's just a different way of writing ordered pairs. And they just try to represent it in all these different ways. And then the 6 goes with the 100. And then maybe we have 7 going with 200. And then -3 with the 300. So with this one, we look at those domain values and see, are any of the domain values repeated? And with the mapping, you're just looking, are there 2 arrows coming from the same x value? And there aren't in this one. It's okay that over here that we have the y value 200 repeating. That's okay. That's legal. You can do that. But you cannot repeat x values. So none of the x values have two arrows coming from them. So that makes this one a function. It does work. It is, yes, this is a function. So remember, y values are okay to repeat, x values are not. All right, so let's do another mapping because that's the one that you don't see quite as often. We see lists of ordered pairs, we see tables a lot, but we don't see mappings very much over the years. So a couple bubbles: domain, range. Maybe you got 3, -8, 10, -6, 2, -5, and 7. And they start mapping those x values. So 3 to 2. Let's do 8 to 7, 10 to -5, -6 to 2, and then maybe 3 also goes to -5. So here we have that x value, 3, has two arrows coming from it. So that tells me, hey, this is not a function. It has repeated x value. So far we've seen a list of ordered pairs. We've seen a table format, still looking for repeated x values. And then we've seen these mappings, these bubble maps from domain to range. And again, we're just looking for repeated x values. Another way that they might represent something that we're trying to test whether or not it's a function is with a graph. And I'm just going to draw a sketch of a graph. You don't have to have any kind of, as far as graph paper with this. And my OCD makes me want or
Mr. Ishmael, can I ask you a question?
Yeah, go ahead.
On the last one, you said that the X value you did repeat, that's domain, right?
Yeah.
I only see 1, 3. So what am I missing?
All right. So there's 1, 3, but there are how many arrows coming out from that 3? There are 2. So it creates two ordered pairs. It creates ordered pair 3, 2, and 3, -5. So there's where the repeat is. Out of that, multiple arrows coming from that is where the repeating happens.
Thank you.
Yeah. All right. So I'm going to sketch a graph here, and we're going to do a test to determine if it's a function or not. So I'm just going to draw the coordinate plane, just an x-axis and a y-axis. This example E, and you've got a relation, but it's drawn as a graph. So it's just let's do an easy one to start with. Let's just do this straight line that's like that. Okay. What we're looking for here is, do x's repeat? Well, technically, this blue line represents just an infinite number of ordered pairs. That's what that blue line represents. We could list out a bunch of them, but we never could list out all of them. It'd be impossible to do because we just always could find one in between the two that we've already listed. But this blue line represents all those ordered pairs. So there's got to be a better way. That better way is what's called the vertical line test. And the vertical line test, what you're doing is you're trying to lay a vertical line on this graph, and you're looking to see if it will touch that graph in two places anywhere you lay it. So if I drop a vertical line just right here, how many times does that red line touch the blue one? Once. So that's okay. So if I try to lay that vertical line anywhere else on there, say I put one right there, how many times does this vertical line touch the blue line? Once. No matter where I put this vertical line, we see that it's only touching that line, that blue line, one place. Okay, so that means that x's aren't repeating. So I'm trying that at any place that I can to try to see if I can make it touch twice. If I'm dropping a perfectly vertical line, it's not going to touch twice at any point there. So this one passes, and it is a function because it only touches one time. Okay, so this one passes because it only touches one time. So yes, it is a function. It passes the vertical line test. And I'm going to show you example one that fails it in just a second. And I think that'll really make some sense once you see something that does not pass the vertical line test. So again, I'm just going to sketch a coordinate plane here, X and Y, and then I'm going to draw a relation. So here, this is a sideways parabola is what that shape's called. We won't do that very much, but it's an easy one to test with the vertical line test. Again, the blue line represents ordered pairs. That's what it represents. We could list them out, but we never could get them all. Okay, so if we drop a vertical line, if I drop that vertical line just right here, it hits right there and right there. That spot where it hits is an ordered pair everywhere it hits. Okay, so there's a place where you've got an X value and a Y value, and here you got the same X value, but you got a different Y value because they're in different places, right? So this has the same X value but different Y values, and it's happening twice. So that's what the vertical line test really does, find us repeated X values if it fails it. So this one hits twice, so it is not a function. It fails the vertical line test. And if I put letters there, but we could put numbers there and kind of pretend we knew what the numbers were on that one. This X value might be the number 3, and the top Y value might be 5. And then this bottom one, the X value is still 3, and the Y value might be negative 2, something like that. That's two different ordered pairs that have the same X value. So that's why this is failing the vertical line test, and it's not a function. Okay? The vertical line test does find us places that there are repeated X values. There's only one place that I could place that vertical line and it not touch twice, and that would be way down here right at that edge. See how it's barely touching right there? That one single place passes the vertical line test, but there's just tons of places where it fails it. So if it fails it in one place, it fails it completely. Okay, so make sure you're checking your graph to see out of that, and you don't have to draw the vertical line. If you just take your pencil and lay it on top of the graph, that works perfectly fine to test with. For the most part, nothing's going to be that picky as far as testing for vertical line tests. Now, as we talk about relations, we talked about domain and range of those things. So let's talk about domain and range of a function or of a graph and kind of where things are going. If we've got a list of ordered pairs or a table like we did here in the first 4 examples, the domain is just a list of all the X values. The range is just a list of all the Y values. That's easy to do. When it's a graph, it's a little bit more difficult to do because you got to look at it and you may not see numbers out of that. So that makes it a little more difficult. I'm going to draw the next couple of graphs. I'm going to put some ordered pairs on there so we can get some numbers and work with them to talk about the domain and range of that. So we're going to test for a function. And state the domain and range. Okay. Again, if it's a list, set of ordered pairs, it's really easy to test for a function, really easy to state the domain and range. The domain's the list of the X values. The range is the list of the Y values. Super easy to do. When it's a graph, that's when it's more difficult. So let's look at one of those. So I'm just going to sketch the graph that I want to talk about, and I'm going to put an ordered pair in there that can help us determine the domain and the range out of that. So I'm going to draw this shape, and I'm going to put this point right here. I'm going to tell you what that ordered pair is. That ordered pair, let's say it's -2, -4. 5. That's the ordered pair that I've placed that dot in. All right. So because I have an ordered pair there, that's going to help me with the domain and the range of this particular graph. The first thing that I want to do is test whether or not it's a function. So would this one pass the vertical line test or fail it? Drop a vertical line right there. It only touches in one spot. So that part's okay. Maybe if I drop it right here, that still only touches in one spot. Maybe right there, still only touches in one spot. So it looks like no matter where I place that vertical line, this is going to pass. So this is a function. Let's take that and state the domain and the range of this particular graph. Okay. Remember, domain is x values. So x values are left and right. Okay. So when we look at this graph, if we're thinking domain, we're thinking, I'm going to read this graph from left to right. So when I see this arrow on this left-hand side of that, it's going up and kind of out to the left, further and further. Okay. So that tells me that the x values are going to keep going to the left. And so that's going to go toward negative infinity. Like, it'll take it a while to get there, but it'll eventually get there sometime. And then to the right, this arrow is going up, but it's also kind of going out some. So it's going to keep going further and further to the right. So the domain is going to be all the real numbers because there are no spots that are skipped in this graph. There are no holes in it. It's continuing all the way across from left to right. So all the domain is going to be, we're going to write it as a set, all x's, and then that straight up and down bar that we talked about the other day, that just says all the x's such that it's a real number. So we're going to say it's all real numbers. Because there are no places that's messed up there. Because it is a function and everything happens really nicely there. Okay. The range, when we talk about the range, we're talking about how it goes up and down, right? So if we read this graph, normally, we're used to, when we're talking about domain, we want to read from left to right. When we talk about range, we want to read from bottom to top in functions. Okay, so what's the lowest point on this particular graph? Yeah, that y value of a -5 is the lowest spot. So our range starts at -5. And then what do both of these sides of this thing do? They go up, right? So if it's going to start at -5 and go up, so our range is going to be all the y values as long as y is greater than or equal to -5. So that inequality symbol there, greater than, and then the bar under it is equal to, because -5 is one of our y values because it's marked on the graph. So that tells me that the range starts at -5 on the bottom and goes up. Okay, that's taking a graph and trying to build the domain and range off of that. So again, domain, you're going to read, start on the left, work your way across to the right. Range, you're going to start at the bottom and work your way up. Okay, always remember to start on the bottom, work your way up. All right. Let's look at another graph. These are sometimes a little tough sometimes. But again, I'm going to draw a graph. I'm going to put some ordered pairs on it that can kind of guide us in how to do things. So I'm going to put an ordered pair here. That ordered pair there is going to be -2, 0. And then I'm going to put another ordered pair over here and put it at 2, 0. Put an ordered pair up here. I'm going to call it 0, 5. And I'm going to put one down here and call it 0, -5. And then I'm going to draw this kind of football shaped graph. So again, remember instructions were to decide if it's a function or not, and then state the domain and the range. Whether it's a function or not, you can still state domain and range. For this one, let's first decide, is it a function? So since it's a graph, I want to do the vertical line test. If I drop the vertical line, right there, hey, how many times does that hit the blue line? Twice. So that tells me that this is not a function. So it's not a function, but that doesn't change the fact that it has a domain and a range. Okay. Now, if we talk about domain, we're going to read it from left to right. So if I'm reading from left to right, what's the first x value that I encounter from left to right? -2. So my domain is going to start at -2, and then what's the furthest one to the right? +2 there, right? So it's going to end at 2. All the x values that work are right there in the middle. So we're going to build an inequality for that. So it's less than or equal to in both spots. Because that tells me that x is between -2 and +2, including both of those. That's why the equal to mark's there, because they're filled in dots on my graph. Okay, so that would be the domain of this particular function. It would start at -2, go all the way to +2. The blue line does definitely cover all of those x values between -2 and +2. It actually covers them twice because it's on the top and the bottom. So definitely covering those. Now the range, remember where we're going to start reading the range? At the bottom. So what's the lowest y value that we have? -5. So my range is going to be y such that it starts at -5 and goes to where? What's the +5 is the highest one there. Doesn't have the arrows extending it up forever there, so we know it's going to stop at 5, and our y values are between those. So again, we're going to do the less than or equal to marks in there to get the between. And there we have the domain and the range of that particular relation. Remember, it's not a function because it failed the vertical line test, but it is a relation. It still has a domain and a range. So as you're looking at graphs, remember, read it left to right for domain, read it bottom to top for range, and I think that'll help you be able to decipher the domain and the ranges of those. And testing for a function is going to be the vertical line test every time if it's a graph already drawn for you. If it's a list of ordered pairs, just look for repeats on the x's. If you don't see any, then it's a function. If you do see some, it's not a function. Okay. All right. So the next type of thing that can happen here with functions is, what if they don't give us a graph? They don't give us a list of ordered pairs. They don't give us a mapping. They give us an equation, and we've got to take that equation and deal with it as far as finding the domain and the range. Okay. So let's look at what we do with that. So the domain of equations, and in this case we're dealing with functions. When you're dealing with domain and you've got equations, there are only two things that you really have to look for, and I call them two red flags. So the first red flag, and then I'm going to have a second one. Okay, there are two red flags that can happen. If these red flags show up, then you've got to do some work. If these red flags do not show up, then there's a default domain that we're going to use, and we're going to talk about that. So the first red flag that could happen is that there were x's or an x in the denominator of the fraction. If there's a fraction in there, there may not even be a fraction in there. Remember, the denominator is the bottom part of the fraction. Okay, So there's a red flag that shows up if there's an X in the denominator of the fraction. Okay, that's one of the red flags for domain. The second red flag is there's an X on the inside of a square root. Remember that square root symbol looks like that. So X on the inside of a square root. Those are the only two red flags that could show up. If there is no red flag, then the domain is by default all real numbers. Okay. So anytime we're dealing with functions, we start out with the assumption that the domain is all real numbers. And then the red flags can cut it down a little bit and can tell us what numbers don't work or what numbers are the only ones that do work. Okay, so we're going to go through some examples here and look for those red flags, and then I'm going to teach you what to do when those red flags show up. Okay, so we're going to get into solving a few equations in this section, and then we'll do a whole section later on today that's just actually is solving equations. Yeah. Yeah, sure. Oh, that's fine. So if there's an equation or a function, we want to find the domain of this of the function. All right, so we're not worried about range at this point right now. We're just focusing on doing the domain parts at this moment. So later on, I believe, yeah. Example I. Let's say we have the function f of x, and f of x it's the same thing as y. This is function notation, and I'm going to kind of introduce it here and get us used to seeing it because we're going to use it here in a little while. And let's say we just had something simple like x plus 4. So basically, this problem says y equals x plus 4. What I'm looking for are the red flags. Is there an x in the denominator, or is there an x in a square root? If I look at that problem and there's not even a fraction in it, the first red flag can't even be there, right? If there's not a square root symbol in there, that one can't be in there either, right? So this one has no red flags, okay? If there are no red flags, then the domain is going to be that default. All x's, as long as it's all real numbers. We wrote this earlier. No red flags, the domain's all real numbers. I want to go ahead and introduce another notation that you might see in your textbook or on the quizzes and things and in the labs. It's called interval notation, and it's just a different way of writing this domain. The interval notation for that, interval, interval, interval notation. All real numbers, it starts at negative infinity, so the negative and then an infinity symbol, which is like a sideways 8, all the way to positive infinity. Parentheses on each end. That's not an ordered pair. That's the parentheses means not including these numbers, and it's like we start at negative infinity. The comma means okay, we're going until we get to the next number listed, and that next number is positive. Excuse me, infinity. All right. So thank you. So from negative infinity to positive infinity is the same thing as all real numbers. Okay. We're going to kind of try to introduce that as we go here. Be able to kind of work with both of those. Some people are really comfortable with this way of writing it and eventually catch on to this. Some people really just catch on to this really fast and like writing it in interval notation better. Got to be able to do both though. All right, so let's look at another problem. Say we had f of x is equal to 5 over x plus 2. Well, I see a big fraction. So that makes me think, hey, there may be a red flag. So the red flag exists if there is an x in the bottom part of that fraction. Well, if I look at this one, hey, there's an x in the bottom part of that fraction. So there is a red flag right there. It tells me, hey, there's something to do with the domain on this one. Okay. So what I want to do when there's an x in the bottom part of the fraction or in the denominator, what you need to do is take the denominator. So we're going to take the entire denominator, x plus 2, and we're going to set it equal to 0. Okay, so set denominator equal to 0. And then we're going to solve that equation. X plus 2 is equal to 0. And by solving that equation, I mean just get x by itself. Okay, so this is where, we go through, okay, if I'm going to get x by itself, it says x plus 2. To get rid of the 2, they're adding it. So to get rid of it, I'm going to do the opposite of that, which is subtract it. So I'm going to subtract 2 from both sides to move it over to the other side and get x by itself. So that cancels it out here. Negative 2. Negative 2 is going to be the number that we leave out of the domain. Okay. The reason negative 2 is cut out of the domain is because if I put negative 2 into the fraction here, what's negative 2 plus positive 2? If somebody owes me $2, that's negative 2, right? And they pay me $2, how much do they owe me now? Nothing. They owe me $0. What's the only number in the world we can never divide by? 0. Okay, so that's what we're doing here is we're finding what number would put a 0 in the bottom of this fraction, which is an undefined operation. You can't divide by 0 because you can't break something into 0 parts. It's either one part or a bunch of parts. It's never 0 parts. Okay, so what we're going to do for the domain, the way we're going to write this, it's really easy in the interval notation or the set notation, and it's not too bad in the interval notation. Okay, so we got all x's such that instead of writing all real numbers there, we've got an exception. We've got a number that it cannot be. We know x cannot be negative 2. So it's really easy to write in set notation x, and then you put an equal sign with a slash through it. That means x does not equal negative 2. And that's the domain of that particular function. In interval notation, we're cutting out the negative 2. So we're going to start at negative infinity. We're going to go all the way up until we get to negative 2. So that's the next place we'll get to. And then we're going to cut out negative 2. So I'm going to put a parenthesis right there that says, hey, negative 2 is not included in this. But any number that's not negative 2 is. So I've got to join this. So I'm going to put a U for union because that means putting them together. And then I'm going to pick up at negative 2 again. But it's a parenthesis right there. That parenthesis says, hey, I'm not counting the negative 2. I'm counting just right after it. So like negative, be like negative 1.9999999, is where that's at. Okay. And then I'm going to go on up to positive infinity from there. So I'm cutting out the negative 2. One thing that can maybe help this, the interval notation idea, is to think about it in terms of a number line. So on a number line, negative infinity is way out here and positive infinity is out there. That's what the arrow tells you it's going to. Negative 2 would be somewhere here in between that, right? The domain of this, it's starting here at negative infinity and going all the way until it gets here to the negative 2, and then it's leaving it out. It's jumping over it and then picking up and going all the way to positive infinity then. Okay, so that's what the interval, if you'll think about the interval notation, I think visualizing it with a number line can sometimes help you see, hey, where you're jumping over a number, that's where you're going to put the parentheses with the U. That's what jumping over that number is what that does. Okay. All right. Let's move on. There's a domain there, so don't get confused. That's what we're after there. Let's look at another one here. Let's say we had f of x is equal to the square root of x plus, or not x plus 5. Let's do x minus 5. That's it. Change it up from a plus to a minus. All right. Well, remember my red flags. They were, if there's a fraction and an x in the bottom, well, that's not what's going on here. It's not a fraction, but there is a square root symbol, and the x is inside of that. Okay, so that's our big red flag, is we got a square root with an x in it. So what you want to do then, if there's a square root and an x inside of that, set the inside of the square root greater than or equal to 0. So in this case, we're going to take x minus 5 and say it's greater than or equal to 0. The reason that we do that is because when we're taking square roots, we can take the square root of 0. That works. Square root of 0 is always 0. So that's why it's equal to 0. We want it greater than 0 because if we take the square root of a negative number, that's where we get into the complex number system that we talked about on Tuesday. We're dealing with the real number system. Anytime you're talking about domain, you're talking about the real number system. The complex numbers are not part of the domain. Okay, so that's why we're setting it greater than or equal to 0. It's always going to be that way. Whatever's inside of the square root, set it greater than or equal to 0 and get x by itself, or whatever letter we're dealing with there. So for this one, how would we get x by itself? They're subtracting 5, so the opposite of that would be add 5. So I'm going to add 5 to both sides, and there I have x. It's got to be greater than or equal to 5. As long as x is greater than or equal to 5, I can take the square root of that answer. Some of them are going to be decimals. Some, if it is 5, it's going to be 0. But what this does is it creates the domain for us. And here's the wonderful thing about the square root ones. You just take this and copy it straight over. X has got to be greater than or equal to 5. You don't have to put a not equal to or anything like that. It's straight up, copy it straight over, whatever the inequality is. Okay. In interval notation, if it says x is greater than or equal to 5, then what's the smallest number that it could be? Because you remember, we start with negative infinity, but if it's greater than or equal to 5, it has to be greater than or equal to 5, then all those negative numbers don't work anymore, right? And the smallest number on my domain is the 5. And then it goes up from there, which would be the positive infinity part. Here's the difference on this. You're going to put a parenthesis on the infinity side, and on the 5, you're going to put a square bracket like that. The reason you're going to do a square bracket is because the 5 is included. We're using the 5 because the equal to mark on the inequality, This equal to mark here makes us use a square bracket right there. And we talked about when we were listing sets, we didn't use a square bracket. We used those curly braces. It's because square bracket had a meaning later on. Okay. So again, be able to do set notation like this, but we're going to be eventually transitioning to where we're using interval notation some too. Okay. So we need to be able to kind of try to do both out of this is what we're trying to build up to. All right. So domain, you're looking for red flags. Red flags exist when there's a x in the denominator or an x inside of a square root. If the x is in the denominator, set the denominator equal to 0, solve it. If x is under a square root, you set the stuff inside of the square root greater than or equal to 0 and solve it. And that's how you're going to build your domains. They don't get too complicated with the equations in this section. Nothing really strenuous. As we go further in the class, you're obviously going to get tougher equations to deal with when we're finding domains, but they don't get too bad in this particular section. It's pretty easy, actually. But just got to remember, get those two basic rules about the red flags going. You'll be fine. All right. All right. This section has a lot of stuff. It's all about functions. So the next thing we're going to talk about is using function notation. Well, hold on. Let's do another domain one real quick before we get away from that. I want to make sure. I'd hate to leave you hanging on that. So let's do this. A couple more of these real quick, and let you make sure you got that idea. F of x is equal to 6 over 2x plus 7. Let's do that one. And we're going to find the domain of that still. What do we do to find the domain of this? Good job. Absolutely. And solve that. So this is a little tougher solved than the last one we did. So what do we do to solve this one? Absolutely. Yes, you do want to get rid of the things that don't have the variable first. So how do we get rid of that 7? That's right. So subtracting 7, that's going to cancel it out on that side and just leave us 2x, and then 0 minus 7 would be negative 7. And when they're mashed together like that, 2x means what operation is going on between the 2 and the x? They're multiplying, and the opposite of multiplication is division. So we're going to divide by this 2. And that's going to leave us x. And I'm just going to leave that as the fraction, negative 7 over 2. You might be inclined to want to change that to a decimal or to a mixed number. For the most part, we don't do that. We reduce the fraction if it will, and leave it as a fraction out of that. Don't change it to a mixed number or to a decimal. Try to leave it as a fraction out of that. So that tells us that our domain then is all x's as long as x does not equal negative 7 over 2. That's the interval or the set notation for that. The interval notation, remember, we're going to start at negative infinity. We're going to go to the number that we're cutting out. We're cutting out negative 7 over 2. Parenthesis, u, parenthesis, negative 7 over 2. And then we're picking up and going on to positive infinity from there. All right. So interval notation is going to take a little bit. It's probably the most new thing that you've seen. You may not have seen it at all in a previous math class. A lot of high schools don't teach interval notation or didn't. I think the standards are kind of changing to where we do now. But I know I never saw it in high school when I was, and I teach high school now, and I teach it in my high school classes, but that's just because I know where you're going. I know if you're going to go to college, you're going to see that. So I try to introduce it to my students now. All right, so that was not too bad. Let's do one more domain problem, just so we can feel a bit more comfortable with it. Let's say I'm going to change it to g of x. That doesn't change anything. That just is a different name for a function. That's still just like y. And then square root of 3x plus 5, and then a plus 8 on the outside. So this is where sometimes we can get confused with what to work with and what to not even worry about. So with this one, we got the square root symbol, so we know the red flag is, hey, you got a square root with an x in it. So what do we do in order to find the domain of that? Zero, yeah, that to zero. This plus 8 that's on the outside really has nothing to do with the domain. It would affect the range, but it does not affect the domain. So it's only the stuff on the inside that you have to worry about as far as domain goes. So if there's anything on the outside of the square root symbol, you don't worry about it. It's kind of like the top part of that fraction on example L. That 6 up there, we never touched. We don't have to worry about it at all. So the domain is not affected by that. So then let's solve this particular inequality. So what do we do first?
Take away 5 on both sides.
Very good. Again, removing the things that don't have the x first to get x by itself. And then so that's going to be 3x is greater than or equal to negative 5. And then divide by 3. Yeah. And leave it as that fraction, not equal to, but greater than or equal to, negative 5 over 3. The only thing that I caution you here is if there's a negative in front of the x, when you divide, you have to flip this symbol over. That's the rules with inequalities. We'll talk about that later when we do the whole section about solving inequalities. That's the goal, is to solve them. It doesn't happen too much in this section, but if you multiply or divide by a negative, you have to flip the symbol over with the inequalities. So it would just turn around if you multiplied or divided by a negative to solve. We divided by positive 3 here, so we didn't flip it. So that's the right way. All right, so domain is easy on this. For the set notation, it is anyway. You just copy that inequality. That's a pretty good, easy way to do that. Interval notation, the lowest number is negative 5 over 3. And it's going to go up from there because it says x is greater than that. So, again, bracket on the number, parenthesis on the infinity, because you never can really get to that positive infinity. So you can't include it. And there would be the interval notation for that. I boxed them in separately. All right, let's get to the probably the easiest part of this section. This is a lot of stuff in this one section that we talk about, but it's all the stuff with functions. So it's not too bad. But this is the easy part, so get a break from the hard part and go to an easy thing, and that's evaluating functions. Evaluating functions. Evaluating functions, you might also see it called function value. Sometimes if you need some help with this and you Google evaluating functions, you might find videos that say function value. They're the same thing out of that. So evaluating functions, really the easiest thing in this section. F of x is equal to 3x minus 7, and it asks us to find f of negative 2. All right. All that means, it's fancy notation for saying plug negative 2 in for x. That's all that means. Plug that in for x. So f of negative 2 is 3 times negative 2 minus 7, which we did evaluations on Tuesday with variables in an expression. The only difference is here is that we're dealing with a function, okay? This is f of negative 2. It's not f times negative 2. You're not going to get f by itself here. That's just saying, hey, this is the x value is negative 2. We want to find the y value that goes with it. That's what we're doing. We're finding an ordered pair is really all we're doing. So 3 times negative 2 is negative 6, and then minus 7, and that'd be negative 13. So f of negative 2 is equal to negative 13. And just as a side note, you want to remember that this creates the ordered pair. Negative 2, negative 13. That's what that notation on the left says. Hey, this is the x value, this is the y value. That's all that it really is making out of this. You're just plugging that number in for x and working it out. Okay. Let's do another one. Maybe it's a little more difficult, but still very simple idea. Simple. G of x this time. X squared minus 3x plus 7. And they want us to find g of negative 4. All that means is take negative 4, replace all the x's with it. G of negative 4 is going to be parentheses negative 4 squared minus 3 parentheses negative 4 plus 7. I could work that by hand. I'm gonna show you with a calculator here just to get us practicing with that calculator a little bit more too. But order of operations would tell us to square the negative 4 first and get 16, and then do the multiplication. Negative 3 times negative 4, which is positive 12, and then plus 7, and then we would do that addition last. 28 plus 7 would be 35, I believe is correct. I'm going to show you with the calculator how I would do that. Just really simple. But I just do parentheses negative 4, raise the second, right arrow key to get out of the exponent, minus 3 parentheses negative 4, close the parentheses, plus 7. So I'm just typing that in exactly like I've got it written at this step. Use those parentheses. If you'll have that habit of using those parentheses, it'll keep you from getting wrong answers when you work that out with the calculator. And then crank that out, and I get 35. So it means I did it right. I hope I did. Be embarrassing if I didn't. But it's happened before. It's okay. Not a big deal. All right, so g of negative 4 is equal to 35. Remember, that creates that ordered pair. Negative 4, positive 35 is what it's doing. We're just doing function value here, or evaluating functions. That's all that's doing. So if it's an equation, you're just plugging that in the place of x and working it out. I guess the confusing one that or type that can happen in this section with this particular type of problem is if you're given a function and they just say f, and it's a set of ordered pairs, like it's a relation, it's a function, and you got a set of ordered pairs like negative 3, 5, 0, 3, 3, 1, and maybe negative or 6, negative 1. You got a set of ordered pairs like that, and they want you to find f of 3. These are really easy. You actually don't have to do any math to do it, but it's a confusing problem because you don't have anywhere to plug the 3 in. You're so used to doing function value by plugging 3 in for x. But f of 3 just means, okay, where is x3? So I go up here. Well, this first ordered pair, x is -3. That's not the one. The second ordered pair, x is 0. That's not the one. The third ordered pair, hey, x is 3 there. So that means, hey, the answer is the y value that goes with it. So it's just 1. So f of 3 equals 1. Remember, function value finds you an ordered pair. So that's the relationship that we're dealing with here. So finding f of 3 just means, okay, find x being 3. So I go through my list until I find the one that has x being 3, and then I pick up the y value that goes with it. That's all there is to doing that. It looks complicated, but it's really one of the simplest ideas. We'll do another one with this same problem. Let's say they ask us to find f of 0. Well, f of 0 means where is x 0 at? So I go through my ordered pairs until I find the one that has a 0 in the place of x. That's that second one there. What's the y value that goes with it? 3. So the answer is 3. Same idea if it were a graph drawn and they had the ordered pairs marked on it and they ask you to find a function value, they're telling you the x value to go to, and then you get the y value that goes with it. That's all you're doing is pulling off an ordered pair. Is what you're doing out of that. So it's I guess the ones that I get the most questions about in this particular section are those, and it's one of the easier things, but you just got to remember, hey, function value is just an ordered pair. So they give me the x value. All I got to do is find the y value. It's not hard to do. It's just something you got to look at. All right, last thing in this section, then we'll take a short break because I know it's been a lot of stuff in this one section. So we'll take a short break after this. And it's increasing, decreasing, decreasing, and constant intervals. All right, so increasing, decreasing, and constant intervals. So what's going to happen is they're going to give you a graph, and I'm just going to draw a graph, x and y coordinate plane, and that graph's going to have some ordered pairs on it and some lines. So I'm gonna draw that graph. All you've got to just kind of make yours look like mine. I'm gonna put some dots on here and some ordered pairs that go with those dots. And then I draw the lines. They don't have to be at the perfect same angles. Just kind of got to be going the same direction as that. Yours doesn't have to be exactly the same. It's just got to look something like that and have those ordered pairs out of that. Okay. And this would be example Q, and it's the last one we're going to do for this section. So what we're going to do is we're going to look at this graph and look for increasing, decreasing, and constant intervals. So an increasing interval would mean that as I move from left to right, it's going up. Okay. So again, it's just like the idea of domain. We're going to read it from left to right. And if you're going up from left to right, that means you're rising from left to right. So if we look at this first little leg of this graph, it's got an arrow pointing down saying that this is going that direction there. But if I read it left to right, is that line getting higher as I move from left to right? If I'm moving from left to right, the blue line is going up, right? So that's an increasing interval, okay? Because that line, as I read it left to right, it's going up and to the right, okay? So we have an increasing interval, and it starts at negative infinity because down here on the bottom of this, there's an arrow, and it goes on forever. If there were a dot and an ordered pair listed there, we would list the x value that where it starts. As I read this line from left to right, I get up here to this ordered pair, this dot right here, and the line doesn't keep going up from there. It flattens out. So that's where the increasing interval stops. It stops there at the x value of -2. I'm going to put a parenthesis on that because the -2, 6, that ordered pair there, that's the place where it stops increasing, but it doesn't necessarily include the -2, 6 as part of the increasing one, and we're not really going to include it as part of this next part either. Okay. As we read it left to right, at -2, all the way across here, what's the line doing? Is it getting higher or lower? Staying constant. That's the constant interval. Okay. So we have a constant interval starting at -2 and going to the x value where the constant interval stops, which would be 7. We're always going to, on our intervals of increase, decrease, or constant, we're always going to use the x values to tell us that, tell us where they're at. Always going to use x values. And then here at 7, what does the line start doing? Dropping from left to right, right? So that's going to be a decreasing interval. And the decreasing interval starts at 7. And it keeps decreasing. All that we can see of this graph says there's an arrow, and it just keeps going that direction, that way. So that's going to go toward positive infinity there on the x values. It's going down the range-wise. It's going to negative infinity, but for x values, it's moving to the right, so it's going toward positive infinity. Okay. Uh-huh. Yeah. As I read it left to right, the line is going up. It's moving up and to the right.
Okay.
Does that make sense?
Yes, sir.
All right, good. Now, it's okay if a graph can have more than one increasing interval. It can have more than one constant interval. It can have more than one decreasing interval, or it may not even have one of those. Okay. Some graphs have all three. Some have just one of them. Some of them have two out of three. Some of them have more than one of each kind. But increasing up and to the right, constant, flat, decreasing down and to the right. Be able to recognize those. And remember, you're always reporting the x values that you're reporting. That's the only thing you're going to report is the x values. The y values, if it asks something about range, that's where they come in. If we ask about range for this one, the range would be from negative infinity up to 6, because 6 is the highest that this graph goes. Okay, so we can get those values if we need to. But again, intervals are talking about x values is what you're going to report out of that. Okay. All right, so that gets the first section of the day out of the way. That was kind of a long one. Let's take a short break. Let's take about 10 to go take care of natural things and just relax for a second. And then we'll come back and do some more stuff here. Okay.